damages and stuff like that, but I feel like that's the extent that we always use. We know it causes some negative impact and fresh is always better, but then there are some newer technology that kind of help to make those frozen product actually as good as the fresh one as well. So there are some changes that we need, but we just don't have that data yet. So
welcome to Meatspad. In collaboration with the American Meat Science Association, it's a platform dedicated to share breakthrough knowledge that is accessible to the global meat industry. On each episode, you'll have the opportunity to listen and learn from meat specialists and professionals about the whole meat industry. This podcast is brought to you by the U.S. Meat Export Federation, Ultrasource, equipment and supplies for the meat and food industry, Viscofan Collagen Casings, the best alternative to animal gut casings for a better taste and sustainable sausage making.
Hello, meat folks. Welcome back to the Meatspad podcast. It's your happy and hungry host, Phil Bass. Today we have Dr. Derico, and Derico, you're going to have to say your last name. I don't know how to say that.
last name's Setyabrata.
Setyabrata.
Yeah.
Wow.
It's pretty mouthful, but it's all right.
It is
Derico is just fine.
Derico's all right? Okay.
Yeah.
Well, Dr. Derico is from the University of Arkansas, and we'll get to that here in a little bit. But I just had a chance to visit a little bit with him about some of the research he's been doing, and I think it's very relevant because it's interesting. We in the meat business have been using freezing for a very long time, but we don't really know what's going on. We haven't studied it, right? And I think we're finally starting to get to a point where not only do we need to better understand it from a cold chain production standpoint, but then also like how is that affecting quality? And so there's been a little bit in the past, but tell me a little bit, where are we right now with freezing as an industry, understanding freezing, and then also tell me a little bit about the project you mentioned.
So I think from what I've seen so far, at least, we definitely as an industry use a lot of freezing. We freeze them, we get them, we either blast freeze them or like we put them in deep freeze. So we do that a lot, but then I feel like with the newer technology coming up, like faster freezing rate and how we're actually processing our samples, definitely there's a lot of changes with that, but then we just don't know. We know that freezing increases some thaw loss and things like that because of the damages and stuff like that, but I feel like that's the extent that we always use. We know it causes some negative impact and fresh is always better, but then there are some newer technology that kind of help to make those frozen product actually as good as the fresh one as well. So there are some changes that we need, but we just don't have that data yet.
Yeah.
So
well, I want before we get into your project a little further, you mentioned something that there is damage to the muscle, and being more specific, it's kind of at a cellular level. Is that right?
Exactly. Yes.
Okay. Share what's happening as far as what is happening at that cellular level. Why is that happening? But then also, is that a good thing or a bad thing? Or a thing?
Well, it's definitely a thing. So what happens is when we freeze muscle, muscle is pretty much meat is pretty much 70% water or like around that area, and then all those water freezes and it becomes ice crystals. And depending on how fast you freeze them, some of those ice crystals really damage your cells, and then those cells are where we actually keep those moisture. And once it's damaged, then once we thaw them, that's where all those moisture start to leak out, and then that's where all the damage from the freezing kind of come up with the discoloration, more like moisture loss and everything like that. So that's definitely happening on that side. But there are some potential benefits in there. There are some studies that shows that with those damages, it's actually improving tenderness and potentially aging it as well when we're aging them. But definitely on that side, a lot more new studies needs to be done to make sure that we're seeing those consistently and how we can actually optimize those process. But so there's generally we see that there are some negative impacts, but then I think if we learn about it more, we can make it into a positive way that, hey, this product even though it's freezing, it's frozen, it's actually able to be improving your quality.
Yeah. In the past, folks would think of freezing as a negative situation, and I believe it probably stemmed back to when processors finally started to truly embrace freezing as a means to maintain a type of product, but maybe it was already real close to its end use time, right?
Maybe,
and now we're making a more deliberate decision to freeze,
Yes.
right? And so now we're trying to figure out when is the good time frame. And in fact, as you've mentioned, it does indeed improve tenderness.
Yes.
But you said we also could encounter some other challenges like color issues as well.
So I think it's really depend on how we're doing it right now, because whenever we do study, like we do it in the perfect conditions. Oh yeah, we're fast freezing it, single line and things like that, making it like very fast.
Yeah.
But then when we're doing to the industry, we're just like, hey, put them all in a box and then put them in the freezer, and that totally change everything.
Put them all in a box, stack all the boxes on
together,
a pallet into
yes.
one big cube, and then hope we freeze that thing eventually,
yes, and
right?
I was like, maybe the center portion over there is still like, still kind of fresh for like 3, 4, 5 days before it's frozen. So
yeah, exactly. Well, and I think there's some research out there being done right now with some other institutions trying to figure that side out. I know our group is very interested.
Yeah, I think
in
that'll be
figuring
pretty
that
cool
out
to
as
see
well.
like what's the actual industry freezing practices, and then what actually they're doing, what they actually want to use. I think that'd be pretty
and
cool
what
to
is
see.
happening? What's the gradient that's occurring in that? And what's the quality now from the product that's maybe on the outside versus what's on the very inside?
Yes.
Right? And I like to, when I've described freezing in the past to folks, I like to think of the muscle cell. It's kind of like a water balloon, and you mentioned it's mostly water in there.
Yes.
And what happens to water when it gets cold or when it freezes? It expands. So you're breaking that water balloon. You're also creating ice crystals depending on how fast you're freezing. And so you're definitely having some expulsion of the contents at some point, and that's that purge loss that we encounter. All right, tell us a little bit about your project that you mentioned to me, and it was on steaks and roasts.
Yeah, so I got a couple of study going on. We just actually finished it. So that study is we're looking into a different product size, so roast and size. Product size definitely impact your freezing rate. The smaller it is, the faster the products will freeze. And then we're trying to see it from a standpoint of like how the sizes differ, and then how the different freezing technology kind of impacted. So like on the industry side, we know they're using blast freezer, but then consumers also now able to buy, if you go to bigger like club size of groceries, things like that, you can buy whole muscle, and then you can, depending on what they want to do, they can cut into steaks, or like they can freeze the whole thing, and then that can impact really differently. So we want to see as well how the kind of like your typical consumer freezing as well, so like the chest freezer and then your refrigerator freezer, I guess that's what I call it, how that impacts the differences and quality from there.
Wow.
So we find pretty cool results. So from the roast size, we found that it actually have a better color compared to the steak. What we think is because we're able to actually get more fresh surface from the roast itself. If we're cutting into, like we're making them into steak, we're able to get more better color from there. Something else that we found was there's a trend that the steak product actually have lower tenderness compared to the section or like the roast sides.
Oh, really?
So there's a trend of that, and then overall consumer did not find any differences.
Okay.
But then there's a trend for like the acceptability is actually decreasing with steaks, and then regardless whether you're using blast freezer, a chest freezer, or like your refrigerator freezer as a steak, it just continues to decrease overall.
So it was noticeable to the consumer in an overall acceptability stance.
But then for scoring wise, it was about the same.
About the same, yeah. Okay. When you're talking about roast, describe the roast for me. Is it just like a 2-inch thick cut,
so for the
or is
roast,
it like a
it
whole
was
muscle?
more like, so for the steak, it was about 1 inch, and then the roast was probably about 4 to 6 inch.
Okay, all right. So pretty solid size, about something you would see in a retail.
Yeah, about
grocery
something that
store
you'll see
kind
on
of thing.
retail. We did 3 different muscles on this study. So we used the loin, the diaphragm, and the top loin.
Okay.
And then I think overall the diaphragm and the loin, the strip loin doesn't really got impacted. The top loin got some different result on that one.
A little
and
different.
Having a little bit more changes on the acceptability from the consumers. I think they have the most drastic one compared
Yeah.
to the others. Yeah.
Okay.
Since 1883, Ultrasource has been a trusted supplier to the food industry. Ultrasource provides superior kill floor, processing, packaging, and labeling equipment and operational supplies.
Something that's been curious to me, and I don't know the answer to this, but I want to get your thoughts and hypothesis is why do we see the color instability of product once we thaw that and try to display it in a retail case? Because if you think about it, there's definitely fluctuations during the year, and it's especially if we're talking about beef, right?
Yes.
Let's talk about beef here, okay? And we have fluctuation in pricing during the year, and so there's better times to purchase certain cuts during the year.
Yes.
And if we purchase them and maybe froze them, brought them back out of freezing when the prices are high, but we bought them low, so we have a good price difference there. We
Yes.
still make a profit. Okay, but we don't get that good color stability. So
Yes.
tell me a little bit about what your thoughts are on why don't we get a good color shelf life in previously
for that,
frozen
yeah.
product?
So I think or at least what have been seen so far is like because of that, when you burst that balloon, like inside of that cell, there's also a lot of other enzyme pro-oxidants and things like that. So when that burst, those that previously was contained and then takes longer to be released, now suddenly like a bunch of them are released to the system, to the meat, and then that's been suggested to be the one that really causing a lot of more that instability. So because of that, more oxidations happening, more discoloration suddenly pops up. So big parts from there, I think a lot of those muscle damages that contributes to their just loss of muscle integrity.
Yeah,
much.
and the contents that are in there, the pro-oxidants, as you're mentioning. You know, I mean, that's kind of been my hypothesis. I don't know if anybody's truly tested that. I think it'd be really cool to see.
I think, if we're able to do some more like, type of metabolomics data and things like that, getting more informations on that, I think it'll be really cool just to see like what's actually being released on that. I mean, there's always that thoughts like, oh yeah, the iron's being released, or like the muscles losing those antioxidants and stuff, but then no one's really, maybe there's a couple old study that does that, but then I think with the more analysis technology that we have right now, I think if we can re-update those informations, I think we can learn a whole lot more about what's actually going on from that process. Yeah.
Well, Derico, for the listeners out there, Derico came from a very powerful lab at Purdue with Dr. Brad Kim, has a good understanding of very large data sets, and so it's going to be cool to see how your career advances with your understanding of that. Yeah. And it's so far beyond my original training and my level of expertise, and it's really neat to see folks like you coming in with this whole new experience. And it's like all I had was just an old hammer, and you came in with a nail gun, and now we're gonna start building houses, right? So
something like that. Yeah, I feel like that's the part of it. Even for me right now, it's like, oh yeah, I understand how to use it, but then what I used about like a year or 2 years ago, a lot of those informations is already like updated like 3, 4, 5 times already, and I'm like trying to keep up, and I'm like, oh my god, this is real difficult. But then it's still really interesting, and then we're moving towards that directions that we have a lot more data, and then can we actually use those data, analyze it on a different way, and then can we get new informations that we can use it to help our industry or things like that, or like find something new that we can help to improve the overall meat.
Yeah. Well, speaking of that, based on your experience with the research you're currently doing, maybe what you've learned in the past, what are some recommendations for our processors who are listening for freezing protocols? We've kind of talked about what they're kind of doing right now in many cases, and it's probably not the best. And so what would you recommend?
I feel like the products that you're using varies a lot. So I wouldn't really tell you like, hey, make it the product smaller or something like that. But then definitely try to freeze it as fast as possible whenever you can. I think that will help you solve quite a lot of your problems, a lot of your purge loss and things like that. I think it will help to solve those. I think that would be probably the easiest one to do, is just making sure that you're not stacking everything like 3 feet high and then causing a lot of like things slowly freezing.
Yeah.
Making sure your packaging actually stays intact
Nice
in
and
the
tight.
freezing process.
Yeah.
I think that will be really important, because sometimes, it looks good in the box, and then after you freeze it, turns out it's the seal break or something, and
Yeah.
then it starts to actually will cause more damage with like potential freezer burns, and then later on when you thaw them, suddenly a lot of purge comes out and more oxidation is actually going on from there.
Yeah.
So during that process, I think controlling those two will definitely help a lot, I
Yeah.
would say.
Yeah. So, okay. Well, and that's been my experience in the past too. I know it takes a little bit more for the listeners out there who are processors to take smaller bites, I guess, and freeze smaller units. Even if it's just boxes that have a little bit of air gap between them, right,
Yes.
or a slip sheet or something.
Yes,
that
I
kind
think
of
that'll
allows for
definitely
that.
help.
Yeah, that temperature to transfer.
Making sure you're kind of like wherever you're freezing them, actually, what you said, having that airflow going around.
Yeah.
I think that's important part, because like that air is the one that really freezing your product.
Yeah.
It's like the touching with the metals or something like that helps, but then that air in your blast freezer are the one that really moves your temperature down.
Yeah.
So making sure that the air has access to your products.
That's
I think
right.
that
You
will be
have to
important.
give it a chance to share that energy.
Yes.
and pull that energy out, right? And so, well, good. We like to ask folks, how did you get to where you are? How did you become a meat scientist? And you're at the University of Arkansas,
I
great
am right
school.
now,
It's
yes.
awesome to have you there. I'm glad that you're there and getting some good recognition. And so, how did you become a meat scientist?
That is a very fun question. I don't think growing up, I come from Indonesia. Meat science is not a thing there.
Yeah.
Growing up there, it's like the animals just look like, okay, I see cow, I see goats and
Yeah.
things like that. And then I come into US, they're like the whole system's very different.
Yeah.
So my background is in food science.
Okay.
And then about junior year, I saw like Brad posted like, hey, I'm looking for undergraduate works in meat science, and I never got taught about meat science. I don't know if what is that?
What is
like,
this?
Sure. And then I join there, and then turns out it's just like it's a lot of things. It's like like for me before, meat is just all right. You harvest the animal, you got the meat, and then that's it. And then turns out there's like a whole lot of thing behind it. If you don't take care of your animal, you're pretty much just destroying your whole product afterwards. And then if you do everything good with your animals, but then you don't process them well, then you're also destroying your product as well. So it's very fascinating for me to select those whole process, kind of how they interacting. And I enjoyed the biochemical work as well, and it's like very interesting how the whole thing works. So that's just, I don't know, it sucks me in after junior year, and then here never expect to be a faculty in Arkansas, but here I am, faculty in Arkansas doing meat science. So it's been great. It's been fun. Yeah.
Well, you've come a long way, man,
Yes,
and that's
yeah.
really cool. And hopefully one day we'll talk Dr. Kim into joining us on the podcast.
I think he will enjoy that.
We'll
I think
get him one day, huh?
He loves to share his research and stuff like that. That'll be really cool.
Well,
A lot of
I've
good
known
study
Dr.
there.
Kim for a very long time. He keeps turning down his interviews, but I'd love to get him on here, especially talked about meat and muscle biology, which is our journal for the American Meat
I
Science
think that would be really
Association,
cool,
so.
because those are open access journal,
Yeah.
and then some of them are, like for our producers or processors, maybe for some of them that are interested, those are freely available for them. It might be, not as easy for some of them to understand it, but then the nice thing is like you can just contact those professors, whoever listed there, and they'll be happy most of the time to share with you what's going on and help you out with that, or like share their study. I think it's a good thing for them to have, I guess, a good tool for them. It's like something.
It's definitely the journal that hopefully most American Meat Science Association members are publishing in.
Yes.
It's robust, and for those out there listening, Derico made a good point that it is open access, which means it's free to access. And so all you got to do, go to the search engine, type in Meat and Muscle Biology Journal if you want to,
Yes.
and you'll be able to access a whole mess of information, and also, like you said, the authors are very willing and helpful
Yes.
to share that information. And so, I didn't expect to get onto the topic of the journal, but I'm glad we did. I think it's important.
It pops up. I think it's
important
cool.
to talk
It's
about.
important.
Yeah, so. Well, Derico, thank you so much for joining us
Happy
today.
to be here.
And
Thank you for inviting me.
we'll keep an eye on how your research continues to progress.
Will do. Yeah, keep on sharing what I have.
Very good. Thanks.
Awesome. Thank you.